I think that we're set to go here. So I said I'd explain this video in the first 30 seconds of the video. So we've been together 3 weeks, putting together a lot of skills and concepts that are just forming. Oh, inchoate, one of our words of the day. So inchoate skills and concepts. You're trying to put them together. And I'm going to try to answer a little bit anyway as to why we study math in this video. Hopefully take you to a place of putting some things together, even though we've only been together 3 weeks. I think you first year study students of algebra should be able to follow this. I'm only going to be doing 2 new things in this video, 2 new considerations, a new axes, so to speak, of where we start to study numerical change from a different perspective, some different values, and also how we can take what we've been studying thus far and use it in another context, same skills. So we'll have at it. I got to make this full screen to make sure that you can see everything. It's rather early. I've been at this for a while, but just getting ready to do the video, but got a nice sunrise here. Wow. Some clouds over the ridge, but very pretty here this morning. And now we're going to get into, all right, let's take what we've been practicing and see if we can apply it to a physical situation. Hopefully during the video, I'll just put my thumb up. Maybe you want to hit the space bar and pause and think about some of the things I'm talking about. I just really want you to follow, and let's see what we can do here. I can't get more light in here, but I also don't have any reflections on the whiteboard here. That means I hope you can see everything clearly and give the things I'm talking about some intellectual considerations, dive deeply into thinking, right? So you certainly have been working with quadratics, x squared plus 6x. I wish we would just say rectangles, but this is a quadratic, a 4-sided figure when we draw it. And if we draw it, we get x times x plus 6. And you've been practicing that skill. You've been practicing writing this sum as a product. And I hope that you recognize that when I say that sum as a product, you connect with the word factoring, because that's what you do in math. You factor things, and these dimensions are factors of this area. Maybe that's where the term came from. I wish we would start by saying sums into products. And we'll be doing that in this class, talking in that fashion. The equal sign means what? May be written as. So this calculation may be written that way. But they're the same calculation. If we put a 0 in here, we get 0 plus 6 times 0, which is 0. And over here, if we put a 0 in, we get 0 times 0 plus 6, which is also 0, getting the same number in, same number out, same number in, same number out. Let's do it with the number 1. X is 1. We get 1 plus 6 on this side. Over here, we get 1 times 1 plus 6, and both of those actually equal 7. So we're creating a different way of expressing the original calculation, and it gives us a picture. It gives us a square. I'm sorry, it gives us a rectangle. So that's nothing new there. But we've also been practicing taking this and reshaping it. Now let's call this the x distance, right? So I've made that the x distance, which takes me to about there. And then that's 6 units tacked on to whatever this is, whatever we decide that x value is, we're tacking on 6 units. And we're going to reshape that, right? We've been practicing that. How do we reshape it? We take a little length off of the longer side, we tack it onto the smaller. So let me get the x value first. That's about to there, yeah. That distance, right? And let's take half of that, which is about this. That's there, and let's take that makes x squared, and that distance here. That's pretty good. And then we look at those areas, and looks to me, and I don't know, this is first attempt here, but this should be bigger than that, because now we have x plus 3 and x plus 3. And I think this is another skill we've been practicing. X plus 3 squared, nothing new, so you do it out. I just keep going. Well, that's equal to x squared plus 6x plus 9. And that's not equal to x squared plus 6x. But we can make it very simply the same calculation by subtracting 9, because we got a marker. Subtracting 9. And that's called completing the square. And it actually has a nice little diagram here. So this was x squared plus 6x, so that's an area statement. This is x squared plus 6x plus 9. That's a new area statement. But if we get rid of that plus 9, then we have the same calculation. Okay. Put a number in. What did we put in? A 1 got us a 7. So let's put a 1 in. 1 plus 3, 4, 4 squared, 16 minus 9. And that's also 7. So we may call this a new name. This is Jim, this is James, this is Shorty. All referring to me, because I was very short in high school. Thank God I grew a little the first year in college. Whew. Anyway, so where are we at now? We're at being able to rename, and that's a graphing form. Okay, so we're going to look at this. This is the same. Y equals x squared plus 6x. Y equals x times x plus 6. And y equals x plus 3 squared minus 9. All three of those produce the same table values. Written differently. Same calculation written differently. So what can we see from each one? Well, the original one, I can see cup shape up. Is there anything else I can see? Yeah, but not immediately. Not immediately. Gotta do some work to see things. This one here, what do I see? Well, I see roots at 0 and -6. So that's 0, that's -6, because, you know, if you get rid of one of the dimensions, -6 gets rid of the width. You get rid of the width, area goes with it. What else can I see? Well, this one here, I can start to see the vertex. Of course, what's the number between -6 and 0? Let's see, like -3 is really important. Oh, -3. And if I put -3 in, I get -9. Roots at 0 and -6. I start to get a little deeper into what's going on. So this completing the square process, you've been studying. How do you complete the square? We've been studying x equals minus b over 2a, which is the average of these roots. Can show that by factoring ax squared plus bx equals 0. And that gets us x. We've been practicing that skill, taking out what's common, leaving us ax plus b equals 0. And those are roots at 0. And what makes that 0? Addition becomes subtraction, multiplication becomes division, minus b over 2a. And what, minus b over a. Those are roots. So what's in between minus b over a and 0? Cutting this in half. Right, if you measure from 0 to this number, if we cut it in half, which is minus b over 2a, well, we got the x value of the vertex of that quadratic, that parabola, that rectilinear calculation. so where are we going with this? What are the advantages to being able to complete the square? Well, if I tacked on -7 here, for instance, well, that's not a problem because you're learning to factor that. X minus plus 7 times x plus 1 is another way of writing that. That's great because that's easy to manipulate. But what if it wasn't -7? What if it was -17? Well, that's a problem because you can't factor that, so you can't get the roots immediately. But you sure can do this. You can do that process. Okay, so what does that process yield? Well, I think if we take our eyes off of this and just look at that, we have already determined that that can be written. Well, here's your chance. How do you write that? Completing the square. All right, you cut that in half. And you form the square. You make sure the numerics are the same. And then we tuck -17 there. And now we have x plus 3 squared minus what, 26? And if we set that to 0, well, I can solve that, although I couldn't do it by factoring. Now it's a piece of cake. You should be able to understand -3 plus or minus the square root of 26. X squared of 26 a little bit bigger than 5. So we get a feel for what numbers get us 0. Right, and that's good. So now, how can we take all of these skills that we've just been learning and apply them to a given physical situation, which is really why we study math, because we're trying to look at the world and make sense of it. Relationships, like at this moment, the marker is a certain height. I throw it up, it comes back down. There are reasons for that, physical reasons. And the only way we can get at those physical reasons is to quantify what's going on, to look at it mathematically. So I'm going to give you a situation here, and I'm going to do a lot of the thumbs up so you can push the space bar and think about it. Just give it a little thought. You're not going to make sense of math unless you start learning to give it a little deeper thought. What's going on? Why? So here we go. I got a soccer ball. I hope I don't fall down when I do this because I don't have a right leg anymore. But I'm going to kick it straight up in the air. Boom! There it goes for 2 seconds. And then it reaches its maximum height. And it comes back down. All right. So let's put that into motion. Let's collect a little data. Let's think about what happens when I kick it. If I'm not mistaken, it goes up. And it keeps going up forever until we're into the Star Trek land, going through space. Oh no, it doesn't keep going forever. It plateaus. And it's not really moving when it plateaus. I'll just use a little arrow here, just to give a little flat, right? And then it comes back down, and faster and faster and faster. In fact, it goes up and it slows down. Oh, I'm starting to see a general shape here. Yes, quadratic, parabola. So here's your first chance at doing something mathematically and actually getting an equation. So we have an XY coordinate system, thank you, Rene Descartes, where height is going to be measured on the y-axis and time is measured on the x-axis. So what we'll do is we'll create a function h of t. We've been studying f of x and g of x, but how about we do height determined by what time in the experiment we're looking at? So can you give me the initial data point? I got a ball. It's 3 feet high. I kick it. You said 0, 3. Ball goes up. Ball comes back down. I catch it on my foot. Oh, no, this time I think I'll let it go and hit the ground. So that's all we're studying. And so that has a domain of Zero, we can use zero. And when it hits the ground, we don't know that yet, but we're gonna find out pretty easily, actually. Well, easy for me because I've been doing it for 45 years. Not easy for you. How are we gonna get you to the not hard part? I guess you gotta consider what you're looking at, think about it deeply, practice those inchoate skills and concepts until you understand what's going on and know why you're doing what you're doing. But if you notice right now, we're already taking our initial skills and concepts that we've only been practicing for 3 weeks, but applying it to a problem to understand the apple hitting Newton in the head. All right, so here we go. Oh yeah, after 2 seconds, it reached its maximum height. I didn't give you the maximum height. I'm going to tell you it's 67 feet right now. That's where it peaked. Okay, so this is not the trajectory of the ball. The ball didn't go, whoa. The ball went straight up, came straight down in a vacuum. And, well, it wasn't a vacuum, taking a little poetic license. But I think we've been practicing that skill, writing that equation. So go ahead and write it. If you wrote it correctly, you would have built it off the vertex, because that's where the pattern emanates from. There's symmetry. So y equals, well, how far did the ball 67 feet high, back to 3, looks like it came down 64 feet. And it took 0 to 2 is 2 units of change, but this is quadratic change. So 2 units of quadratic change means that if we had a square, a 2 by 2 square, 4 units of area have been generated. Well, 4 units of area doesn't take me from 67 to 3, so we get rid of that 4 units. And let's use h of t. I said we'll do h of t, so new notation. But we've studied it, so let's use it. The only way you're going to get familiar with things is to use them and see them. That's called experience. We're trying to get as many experiences with each of these topics on a daily basis. And now we're putting them together. So t time minus 2 squared gives us this shape. And what do I want to match up with a time of 2? 67. Now you do this out, because that's one of the test questions, expanding. All right, so I will expand it. And the first thing I'll do is use the eraser so I don't have to write so much and take so much time, because this video will take a little while. That's minus 16. What have you been learning in class? The shortcut for binomial squaring: square the first term, double the middle product, square the last term, and then add 67. And if you put this together, you should get minus 16t squared plus 64t plus 3. And now I am going to move that over here and call it h of t equals minus 16t squared plus 64t plus 3. What is another test question that you are seeing 2 hours from now when you come to class, or 3 or 4, I don't know how many hours? Oh, you're trying to put this in graphing form. How do you put it in graphing form? You take the gift. We got the variable t. You divide minus 64 by 2 times minus 16. And that's 64 divided by 32 when you get rid of the minus signs, which is 2. And you start there. All right? I don't think I'm teaching you anything new here. That's how you get the value of the input in a quadratic, minus b over 2a. That's what I did. And of course, now that we highlight the number 2, we plug it back in. 4 times negative 16 minus 64, 2 times 64, 128, plus 3. And that gets us the opposite of the first term, plus 3. Oh yeah, 67. Beautiful. All right, so what can we do with this? What kind of analysis have we just created here? Remember, the ball kicked. So I think I can see the initial height of the ball. Because if I put a 0 in, you always want to make a product 0. Because the brain works easily with 0. And if you put a 0 in, those go, and I'm left with 3. There's a product here. There is a product right here. I'm multiplying -16, so I want to make that product 0. What makes that product 0? 2. Very helpful. And of course, it's a maximum because when you square things, you get positive numbers most of the time. The only time you don't get a positive is when you make a 0. You could put any negative in here and square it, it's positive. Times a negative, things are going down. So the maximum occurs at 2 because every other number besides 2 takes this down. Right. What else do I see? Well, that's the initial amount. So I guess then the question is, what is that? Well, that's the rocket taking off. Of course, the motor eventually shuts off, right? And then you're in space, and so we're talking about the in space moment. We're in a vacuum. Remember I said that earlier. So that takes off and goes forever in that direction. Yep. And it looks like initially over 1 up 64, it looks like I have an initial velocity right there of 64 feet per second. But that didn't go forever into space, did it? What brought it back? Oh, gravity. Good old Newton with the apple on the head. Gravity is a force. So there are forces at work. And how do we describe those forces? Well, they could be strong. They could be weak. And so how do we describe strong and weak? We use numbers. Yeah. The bigger this number, the more influence it has in the calculation. So if we wanted to figure out what kind of force it would take to escape the power of gravity, well, that's a physics class. And that's where you're headed. So if you want to understand physics, I guess you better understand math. And that's why we study math. Okay, so we have a skill. It's called completing the square. The way it's taught in a textbook is morphing into an easier situation here for us. The textbook method of completing the squares, not that friendly for algebra students, which is why minus b over 2a is very helpful. All right, so now where are we going? We're going to the eraser. We're going to talk about one of the skills that we have here and how it's helpful and how it moves us into another topic. Let's see, am I covering what I want to cover here? I need at least 3 more cups of coffee at this stage of the day, so let me take a sip and ponder. Yeah, okay. I think I'm all right now. So, completing the square, I'll give you a chance to solve a quadratic by completing the square. And then, something that you can't write as a product. And then we'll morph that process into another topic that actually begins to move you towards your study of trigonometry down the road. And if you understand, or at least start to follow what I'm doing here, it will help you later on in your career. And math is built one concept on top of another historically. And so let's try to follow a little of that historical progression. So right now we've got x squared plus 8x plus 100. I don't think you can do that by writing it as a product. I don't see 2 numbers that multiply out to be 100 that are 8 apart. So how do you solve it? You try? Well, you work with that. You rename it as x plus 4 squared minus 16. And then you add 100. You set it to 0. Well, I wanted to put that there. I'm sorry, I should have been there before. And what do I see? Well, I can immediately see that I'm measuring from -4. I'm plus or minus, thinking the square root of. Got to put these numbers to the other side. It looks like they're going to become a negative. If they're negative, that means I have an imaginary, and it's 84, I believe. All right, so I'm done. If I understand the process that we looked at earlier in the video, it's going to take you some practice. You're going to have to practice that skill. It gets more complicated when I put a number in front, but we're not there yet. We're just, tackling a simple process. Okay. So how's that help us? Well, if I'm not mistaken, you've also been studying the first 3 weeks Pythagorean relationships. You've been looking at things like, okay, that's 4, that's 10, then what's that? I'm hoping you're seeing 100 minus 16. There's 84, coincidental to the last problem. Wasn't intended, but that's the square root of 84. Near 9 units. Near 9. Yeah, the drawing looks pretty good. So that's another topic you've been practicing. Well, what if I said X and Y, just generically? Got an X and a Y, and let's say that that's 5. Well, what equation can I write? I think I can write X squared plus Y squared equals 25. That's what you've been practicing, right? You've been practicing that's a square area, that's a square area, that's a square area. And if I'm not mistaken, this square area isn't changing. Unless you think 5 squared can become another number besides 25, then that number is constant. And if you're starting to see that number change, please, after class today, let's have a little chat. Okay, I know they're very busy in the health center right now, a lot of illness going, but maybe we can book a little appointment up there if you see that number change. So X squared plus Y squared equals 25. If I'm not mistaken, that is an equation, which means that some numbers probably satisfy this equation. And I'll give you a minute to try to think about that. Of course, I'm going to keep talking. Well, when I see this, it kind of reminds me of that a little bit. Yeah, and we've been practicing graphing that form. So how would you graph that? Again, I hope you're using zeros. I hope you're covering it up and saying, oh, if X is 0, Y is 25, and I think that satisfies X plus Y equals 25. Open it up, yeah. And I guess if you covered up the Y, that means Y would be 0 and X would be 25. And that sum is also 25. I haven't said anything new. That's standard form. That's one of the skills you're working on. Could you apply it here? Of course you could. X is 0, Y is 5. Of course, that's being discriminatory, isn't it? We've talked about that, discriminating against negatives. Because I think 0, -5 also gives me truth. I think those things, when I do this, get me 25. When I do this, get me 25. Right? Because I let X equal 0. So, where do we go from there? Yeah, let Y equal 0. And you get 5 and you get -5. And you start to plot those. You start to plot those. 5. All the 5s, right? All the 5s. And what else? Well, a little deeper analysis. I mean, you definitely want to be familiar with the 3, 4, 5 triangle, right? Because it's really easy to work with those. 9 units of area, 16 units of area, 25 units of area. So where would that be on our graph that I erased? 3, 4. We got the 5, we got the 5, we got the -5, and the -5, over 3 up 4, back 3 up 4, over 4 up 3, back 4 up 3. Oh, how about -4, -3? How about -3, -4? Oh, Lordy, I sure look like that's the equation for a circle. Huh. Imagine that. Pythagoras just gave us a way to graph a circle. Hey, what happens if you walk around a circle and you keep going? And you keep, oh, it seems like a repetitive. And if I wanted to graph the heights as I do this, you're not going to study this right now. Some of you are, some of you aren't. But if I wanted to start here and just follow the height of my finger as I walk around the circle, whoa, 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 I get a new kind of graph. And if I wanted to apply that graph to the seasons, summer, hottest temperature, winter, coldest, repeating, summer, hottest, winter, cold. Of course, that doesn't work so much anymore because you folks are going to have to solve climate change, right? So unfortunately, we're starting to get graphs that slowly increase temperature in the summer. Oh, we're not going to go there. We're going to stop. Such a beautiful day. Let's just consider the equation of a circle. Okay. And so what have we really created here? Again, X, Y, and 5, and the relationships that come out of it. Well, what if I wrote X minus 4 here? And well, let's keep it X over here. Let's have X, Y, and 5. So let's do X minus 4. Well, X minus 4 is a new axis. Here's the X axis. X minus 4 is taking away 4 units. And what if I said Y plus 3? Well, Y plus 3 is actually tacking on 3 units to the Y axis. And so what I've created is a new coordinate system where I'm measuring not from 0, 0, right, X, Y, but from, so instead of measuring from here at 0, 0, these are new concepts I'm putting in your head now. X minus 4 means that 4 acts like a 0, and negative 3 acts like this 0. So I'm down here now. Now, where would something like this come from? Well, it would come from x squared minus 8x plus 16. So let's write that up here. X squared minus 8x plus 16. And it would come from and Pythagorean relationship. This area here is that squared, and that squared is y squared plus 6y plus 9. I'm doing nothing new here. Nothing new. We practiced binomial squaring. I expect you to be able to correctly state that. And that's going to equal 25. But let's put all of those numbers to the other side. All right. And if I do, I get 16 plus 9, 25 minus 25. I get x squared minus 8x plus y squared plus 6y equal to 0. If I move this and this over. All right, so what if that is what you were given originally and you wanted to plot this calculation? Well, you could put one number in, another number, and solve an equation. That'd take a lot of time to do it that way. It would be nice if we could write it in the Pythagorean fashion, which means that we take a rectangle and complete the what? The square. We write it as a square area. Square areas allow you to use square roots. So what does this one become? Oh yeah, x squared minus 4x. I'm sorry. Morning here. This one becomes, writing it as a square S. Got to cut that in half. X minus 4. Got to square it. That's 16 units that I don't see there, so I do minus 16. What do I do over here? I complete the square. What do? I cut 6 in half. Y plus 3 squared, and 3 squared is 9. I don't see those 9 units. I get rid of them. That equals 0. Oh, lo and behold, x minus 4 squared plus y plus 3 squared equals, bring those over to the other side, 25. Well, I'm starting to see the x minus 4, y plus 3, and 5 Pythagorean relationship. And what's the easiest way to deal with this? Same way we did x squared. Same way we did x plus y equals 5. Make term 0. So what makes this term 0? 4. And if you put a 4 in there, it's covered up. And you can see 2 plus 3 squared is 5. And if you don't discriminate against the negatives, you can see -8 plus 3 is 5. Well, if we did that to the x's, is there anything preventing us from doing it to the y's? Looks like 9 minus 4 squared is 5. So 9 minus 4 squared gets us 25. If I use what? -3. That's what allows me to cover that up. And not to discriminate against the negatives, -1 minus 4 gets me that if y is -3. And let's plot these values. Now, I don't want to put it on an XY axis. Let's just plot it. Let's plot 4, 2, which is horizontal, vertical. So that's 4, 2. Horizontal doesn't change, still 4, but -8. 9 is horizontal, and that's bigger than -1, so that's 9, -3. And over here, -1, -3. I wish this table wasn't so close to that, but now here's your chance to pause the video and tell me what that coordinate is. What's that coordinate? So you look at these, you figure it out. I'll just keep going. Well, if I'm not making a stupid mistake, it's 4, -3. Let's go back to that drawing. X minus 4, y minus 3, not drawn to scale maybe, or I don't know, talk about that later. But what can I see? That 25 units of area, these square areas have to add up to that, right? And if I make this one 4, well, that dimension's gone. Everything has to come from this. And if I square that, I need the number 5. What makes the number 5? 8? Did I make a boo? I made a mistake here somewhere, didn't I? I'm not going to make this video again. Talking too quickly. Let's see. So if I make this 4, this is 2, or it's -8. -8 plus 3 is -5 squared. So that's correct. So I might have made these. Oh, stupid. There we go. Careless, but I caught it. So now, if I made this 4, then that area is gone. Everything has to come from this side. And yes, -8 plus 3 is -5. -5 squared is 25. Okay, so hopefully you can pause the video and go back and look at what I just said. Maybe you caught that mistake before I did. And if I back to this, x minus 4 and y plus 3, right? If I make that -3, then this side of the Pythagorean relationship is got to be satisfied by that. I've got to make this area the same as that. And 9 does it. 9 minus 4 gives me 5. And that's what's generating this table. So this is kind of a standard form in some ways. You're making zeros so that your brain can get a couple of values. And if you get more values in here, remember we said 3, 4. 3, 4 gave me 5 as well when I squared 3, 4. That should happen here. I should be able to see those numbers. What makes 3? Oh, 7, right? And if I put a 7 in there, I get 9 units. And if I put a 1 in here, I get 16 units. So 7 and 1 satisfies this equation. Now, where's 7, 1? 7, 1 might be, well, over 3 up 4. It's probably right about there. That's probably 7, 1. So I'm manipulating some things. And I've got a new coordinate system here. New coordinate system. 4, -3. So where's the origin? The old origin's here. Right? So I've kind of shifted my numerical perspective. One more level of difficulty in the computational process, but still measuring change from the number 4 and from negative squared change. I don't think there's a single thing I just said that's new in terms of building this skill. So we'll do 3 in a row. Might as well. There's no reason that you can't pick this up. And by the time you do the third problem, I'll bet you half the class has it down. And that's half the class that's watching the video. And the other half of the class that's not. Well, sorry, but now you're behind. I hope you do follow this. So let's just put a couple of things in. Find the center and the radius. That's what I'll be asking you to do. Find the center and the radius. And this skill is essential when you get to a more formal study of trigonometry. So getting good at this now is going to help you immensely in the future. And trigonometry allows us to look at repetitive patterns out there in the real world. So let's do x squared minus 8x plus y squared plus 10y. I'll give you some canned problems. Some canned problems means I'm just going to work with integer values. So 16, 25, 16, 25, 41, we'll just go plus 8. Okay, so you pause the video, take your time to do this. I'm going to find the center and the radius for you. We'll do 3 in a row. I'll let the numbers speak for themselves. I won't even talk. Nice and quiet here. Hope I did that right. I think I did. So the center, 4, -5. The radius is the square root of 49, which is 7. And so what I've created is a side length of x minus 4. I think we had that one before, y plus 5. And 7. That's the Pythagorean relationship. That becomes square area, that becomes square area, that becomes square area. And as one area gets bigger, the other gets smaller. And the interaction gives us that circular relationship. Let's do another one. Solely based on what you've been practicing here at the start. Okay, so let's look at x squared plus 12x plus y squared minus 2y. Let's set that equal to 36 to 37. Let's make that 30, so 27. Okay, nice canned problem, I believe. You pause, do the work, center and radius. X plus 6 squared minus 36 plus y minus 1 squared minus 1 equals 27. I believe if I move these over, 37 and 27, I believe it's 64. So I'm going to move that. I'm going to move that. I'm going to call that 64. And can you tell me the center of the circle? I hope you said -6, 1. That's the center. Square root of 64 is 8. That's your radius. One more. All right. Let's go with x squared plus y squared minus 8y equals 9. Equals 9. What do? We complete the square. Well, this already is 1. I don't need to do it. That is a square. Leave it alone. This one is y minus 4 squared minus 16 equals 9. So what do I have? I have x. I have y minus 4. I have x. I have, when I bring that over, it's 25, right? When I bring it over, I've got x squared plus y minus 4 squared equals 25. So that's 5. I've got this circular relationship. What's our new origin? What number gets rid of x? 0. What number gets rid of y minus 4? 4. So that's our new origin. So that's the center, 0, 4. And I'm moving in this direction. How many units? How many units? How many units? How many units? Square root of 25. 5 that way, 5 that way, 5 that way, 5 that way. I've got the graph. All right, so that was kind of a lengthy video. But what are we trying to accomplish here? We're trying to accomplish those inchoate skills and concepts that are just forming. Right, word of the day. And what are we going to do with those? We're going to build concepts and techniques of study on these initial considerations. If your initial considerations are faulty, boom, the building collapses. So how are we going to get that foundation? So the building doesn't collapse. We're going to practice it every day. We're going to work with it every day. You're going to think about it every day. And if you don't, then don't expect a well-built house. Good luck. Ending video. See you in a couple hours. I'm going to go to breakfast soon.